Okay, so now we're going to talk about Carl Lashley's article on the serial order problem of behavior. And so the serial order, oops. Okay, so today we're going to talk about the about Carl Lashley's discussion about the serial order problem in behavior. And so what this refers to is the question of how does complex sequential behavior get carried out in the correct order, right? So sequential means another word for that is serial, and order means in the correct order. And so how does that happen? So I use this example, but of a skateboarder doing a kickflip. It doesn't have to be that this problem uh, applies to almost all, if not all, complex behaviors, right? But so here, in order to do a kickflip, the skateboarder needs to first pop their back foot on the back tail and then also kind of jump and then slide the front foot, up and a little bit to the left on the skateboard. And then the skateboarder has to jump and raise their legs so that the skateboard can rotate. Um, and then they have to get their skateboard has to get their feet out of the way to let the board rotate, and then locate the skateboard once it flips, and then land it, right? And so, how does this complex behavior occur? And so, behaviorists they have a problem. This complicated behavior is a problem for behaviorists, and they must explain how a sequence of responses get chained into one complex behavior. And the idea was that these simple responses get chained or linked, um, and the and subsequent responses, or sorry, preceding responses will trigger the upcoming response. So I'll tell you what I mean about that in a second. But the idea here was that proprioceptive feedback. So this could be any kind of feedback, but the point is it could be visual feedback, but it could also be the way your muscles feel, where you can perceive where they are in space, that kind of thing. And so the proprioceptive feedback from a given response would trigger successive responses, which would end up combining into a complex behavior, right? So the stimulation caused by the first movement, let's say, uh, kicking this board up while popping the back tail, right? That the proprioceptive feedback that the skateboarder perceives from their own response would trigger the subsequent response, and then the proprioceptive feedback from the second response would trigger the response to the third response, and then the proprioceptive response from the third response, sorry, the proprioceptive feedback from the third response would trigger the fourth response, so on and so forth, until it becomes a complex behavior. And so Carl Lashley rejected this idea. And he said, basically, it's rarely the case that what happens, and this is actually from the book, it is rarely the case that what happens at a particular moment is solely determined by what just happened, right? So what happens at any given moment in the sequence is often a function of what will happen later in the sequence, as well as the overall goal of the behavior, right? So complex behavior is not a simple chaining of responses, or I guess reflex chains is what they call it, but it reflects planning, right? Okay. And some of the reasons for this uh, was that correct movements can occur even when sensory feedback is interrupted. So patients who can't feel because of spinal cord damage, they can still carry out a sequence of movements. So this is a picture of people with spinal cord damage who could not feel the muscles in their hand, I guess, and they were in a dark room, right? So they had severe sensory neuropathy is the idea. But despite, and maybe, and again, they're in a dark room, so they can't see even. And despite the absence of any kind of feedback, they were able to draw these shapes just as, reasonably well, which tells us that they weren't actually, or suggests that that sensory feedback that was not there was not really important for them to actually complete the task. Okay, so the other thing is that movement sequences are often too quick, or can be too quick to be based on any kind of sensory feedback. So if you think about it, producing a movement involves sending a command to the muscles, which then contract to carry out the command. Sensory information from the movement is sent back to the brain, and this loop takes some time, right? But if the sequence of movements is just a link of simpler movements that are triggered by the preceding movement, then you shouldn't be able to perform the behavior faster than it would take for you to register the sensory feedback. However, very skilled typists or even, younger college students, or not college students, just younger people, I guess, younger than me, would be able to text, for example, on their phone pretty fast, and it's probably too fast to to be based on sensory feedback. So, for example, this is a sentence or two sentences that were typed by somebody on a phone texting, and I think this is like the world record, maybe. So I'm not going to read it because I can't, but here you can see that it's pretty complicated two sentences. It's pretty complicated and hard to type. And you can see that it was texted in 18.45 seconds. This is about one character per 100 milliseconds. And the interesting thing is that this is actually twice as fast as it would take for the sort of loop, the reflex loop of communication from your hand or your fingers, let's say, to your brain, and your brain back to your fingers. That loop would take twice as fast. So yeah. The other thing is that errors in behavior often suggest internal plans for later actions. So this is a Psychology Today magazine cover where the guy is putting ketchup. Oops. Where the guy's putting ketchup into his coffee, and you can, which obviously or presumably he did not mean to do that, probably meant to put sugar or cream into his coffee. But one thing you should realize is that this is not a completely random error, right? So it's not like he got the ketchup and threw it over his shoulder, right? That wouldn't make any sense. The person likely had a plan to pour something into the milk, but accidentally grabbed the ketchup and poured the wrong object. And so this is not a random error necessarily because it reflects a part of a plan. For example, if I have my phone and let's say I'm on the phone and I'm washing something with a towel or with a paper towel, and then I hang up the phone, and then I'm done and at the same time, maybe I'm done with, washing the table. I might accidentally put my phone in the trash can, right? So it's not like I threw the phone across the room. I did something that was sort of systematic. I just sort of switched the object that should be doing the action, right? So it reflects a plan. This is also true for a lot of things. So that one's called an action slip. These are action slips that I'm talking about, but it's often the case. You see it a lot with language, right? So we can exchange two sounds of different words, such as, if we're trying to say nightlife, we might accidentally say knife light, right? And that it suggests that when we're thinking about the word or we're trying to say the word night, we're sort of the life part is activated. And so we say knife instead of night, right? And then of course, we switch night, the ite sound with the if sound in life. And so it becomes knife light. And then anticipation errors, I think, are a better example of evidence for planning. So anticipation errors are where you're talking, but you're anticipating a later word. And so that interferes and you accidentally say something that you were planning on saying later. So for example, if you're trying to say, take my bike, right? While you're saying take, you might think of the phoneme bike or buh. And so instead of saying take my bike, you say bake my bike, right? And that's evidence that you were thinking about bike or anticipating bike. And then also, there's also, this is probably even better evidence for, plan or errors that are, that suggest planning, which are word exchanges, right? So if you wanted to say, write a letter to my mother, right? You might accidentally say, write a mother to my letter, right? And which suggests that when you were thinking about, I guess when you're about to say letter, you thought about mother, and so you accidentally said mother. So suggests that you're thinking farther down the line. All right, so Lashley argued that complex behaviors reflect prior planning, but he also suggested that they're organized in a hierarchy of behaviors rather than linearly organized, which is sort of what the chaining uh, of responses implies. Okay, so on the next one, we'll talk about the next video, we'll talk about an actual task, and we'll talk about how it might be hierarchically organized.